Hello everyone. Laplace transform consists of continuous function and non-continuous function. For the continuous function, we have covered the Laplace transform and the inverse Laplace transform, as well as the property of the Laplace transform. And for the non-continuous function, it consists of unit step function, unit impulse function, and periodic function. In this lesson, I will share with you a Laplace transform for non-continuous function, unit step function. Step function is a common non-continuous function. In fact, we can use the definition of Laplace transform as mentioned in the early beginning of this chapter to find the Laplace transform of the step function. So all we need to do is to separate the integration into 2 or 3 or more parts to evaluate according to the numbers of subintervals that the step function have. Now let's go to the example. By applying the definition of Laplace transform, find the Laplace transform of the step function as shown in the figure below. Okay, this function can be represented by the ft equal to 2t. Okay, this is 0, so 2t from 0 to 3. And whereas negative 1 starting from 3, okay, so more than when t more than 3, you have the value of negative 1. So this is the function. So by definition of the Laplace transform, we can find this Laplace transform of the ft is integration from 0 to infinity exponent negative st ft dt. So based on the function that we define here, we can say that the integration 0 to 3 exponent negative st is for 2t dt plus 3 to infinity exponent st dt as negative st multiplied with negative 1. So we can integrate this part using the tabular method. So I write it down here for the tabular method. I assume this is the differentiation and this is integration. So we have this one. The exponent negative st I assume is an integration for integration, and 2t for the differentiation. So I differentiate 2t, I obtain 2, and differentiate 2 again, I obtain 0. I integrate exponent negative st, I obtain exponent negative st divided by negative s, and I integrate again, I obtain exponent negative st divided by s squared. So this is positive, this is negative. So from here, from this tabular method, okay, I obtain 2 times t, 2t multiplied with exponent negative st divided by negative s. So 2t exponent negative st divided by negative s. Then minus with 2 times exponent negative st divided by s squared. So the limit is still the same, 0 to 3 minus exponent negative st divided by negative s from 3 to infinity. So for this, the first part, I substitute the t with 3, okay, and then next to minus with 0. So I have a 6 exponent minus 3s divided by negative s minus 2 exponent negative 3s divided by s squared. Okay, minus with 0 minus 2 over s squared. Exponent negative infinity divided by negative s plus exponent negative 3s divided by s. So this will equal to minus 7. So this one is minus 6 over s exponent negative 3s. And then minus with exponent negative 3s over s. So this one you get negative 7 exponent negative 3s over s. And this one will obtain 0. And then we copy down this one, so we have negative 2 over s squared exponent negative 3s plus 2 over s power 2. This question we only solve using by definition of the Laplace transform, not through the step function. So we found that the integration is somehow very tedious if the subintervals of the step function is many. Thus, finding the Laplace transform of the step function by using the definition of Laplace transform is time-consuming. So to solve this problem, the step function can be changed to unit step function. And unit step function is known as the Heaviside unit step function. Now let's look at the example. Sketch the graph of f1t equal to t, and then f2t equal to unit step t, unit step t minus 2, and f3 is t minus 2, unit step t minus 2. So what is the difference between each? f1t equal to t, this means that we have the graph like this. So if we have the 2 here and we have the 2 here, so this is the graph of t. And second, if we have f2t equal to t unit step t minus 2. So what does it mean here? For t unit step t minus 2, this means that the graph will start from 2 to infinity. So if we have the same graph like this, okay, so the graph starts from 2 to infinity. The fundamental theory is that if you have the t is the graph like this, and we have the graph of unit step t from 2 to infinity, if the amplitude is 1, so if these two graph product, okay, we multiply, so this value multiplied with this value, we will obtain 0 because the value here is 0. Okay, at number 2, the value is here 2, we multiply with 1, you get the value here. Okay, so apart from, and also the same beyond the 2, you have the value, multiply with 1, you get the value. So that's how you get the value of this. Now we go to the third graph, that is the f3t equal to t minus 2 unit step t minus 2. So what is mean here? With t minus 2 and unit step t minus 2, we shift everything to the right 2 units. Okay. So starting from, this is a 2. So starting from 2, we shift everything 2 units to the right. Okay. So this is the f3t. Do you understand now? Okay. Initially we have the t like this. Okay. If we move everything, this graph everything to the right hand side 2 units, so the graph will be like this. But provided your equation is t minus 2 unit step t minus 2. That's the difference. Okay, it's okay. We go to another example. If we have a g1t is equal to exponent negative 2t, so the graph will be like this. Okay, so this is the graph of exponent negative 2t. Now, if my graph for the g2t is exponent negative 2t unit step t minus 2. This, what is mean here? This means that we want to cut the graph of the g1 here starting from t minus t equal to 2 only. So the front part I don't want. We want to chop down. Okay, we just want the graph for unit step t more than 2. Okay, the before 2 we don't want. So the graph will be like this. Okay, we just left the graph after 2. And then what about the third question? That is the G3t equal to exponent negative 2 t minus 3 at t minus 2 unit step t minus 2. It's the same if we have t minus 2 and t minus 2. This means we shift the graph everything to the right hand side 2 unit. So we shift the graph, shift the whole graph here. Okay? So this is the G3t. Do you understand now? What's the difference between the unit step of ut minus 2 and what is the difference of t minus 2 and t minus 2? If we want to find the Laplace transform of a step function, to make it easier, we can change the step function to unit step function. So this is the formula to change the step function to unit step function. For step function in the form of gt, you have g1, 0, t is between 0 to a, and g2 is t more than a, and we have the equation like g1 plus g2 minus g1 unit step t minus a. Or for the step function in the form of, you have g1, g2 and g3, and this is for the g1 is the same and g2 is in between a and b. Okay, so the equation is g1 plus g2 minus g1 unit step t minus a plus g3 minus g2 unit step t minus b. So this is in general. Now let's go for the example. Sketch the graph of the step function below and write the function in the form of unit step function based on the formula given just now. To solve this question, so we compare first with the corresponding function. Okay, gt is equal to g1 from t from 0 to a, and for the g2 is for t more than or equal to a. So if you compare with this the question and the corresponding function, and easily we can detect that the a is referred to 4 and g1 is referred to t squared and g2 referred to 4t. Okay, then we can draw the graph. Okay, how to draw a graph is based on this equation. Okay, based on this function. So when t equal to 0, so ft we substitute in the equation t power of 2, so you get 0. And when t equal to 1, so ft is equal to 1 also. And when t equal to 2, ft equal to 4. And when t equal to 3, ft equal to 9. Then this is for 0 to 3. And then for t more than 4, we use the 4t. So when t more equal to 4, the ft is 4. 4 times 4, you get 16. And when t equal to 5, the ft is 20. And t equal to 6, ft is equal to 24. So we can use this one to plot the graph. Second question, we have the pt equal to 2 from 0 to 3, and t is from 3 to 5, and 1 is t more than 5. Okay, for this question, we compare with the corresponding the function. G1 is from 0 to a. So this means that the a is equal to 3. And then we compare again, G2 equal to 3 to 5, a to b. So this means the b is referred to 5. And then G3 is t more than b. So the again b is equal to 5 and g1 is equal to 2. Okay, g1 equal to 2, g2 equal to t, and g3 is equal to 1. Okay, now we can write the unit step function. Pt is equal to, okay, if you base on here is 2 plus t minus 2, okay, 2 plus t minus 2, and then plus multiply with the unit step function t minus 3, start from minus 3. So unit step t minus 3, and then plus with, okay, plus with this one, 1 minus t for the unit step, t more minus 5. So 1 minus t, unit step t minus 5. So this is how we write the unit step function, transfer from the step function.